Hello everyone. Today we are going to discuss vapor pressure and Raoult's law. So let us first see what is vapor pressure and then how it can be calculated using Raoult's law. So let us start with vapor pressure. So consider any liquid, for example water, in a beaker. Water in a beaker at room temperature, suppose 25 degrees Celsius. So at this temperature, you know, the water molecules, they will possess some kinetic energy. So every water molecule will possess some kinetic energy. Some of them will have low kinetic energy and some of them will have high kinetic energy. This can be shown by this graph. If we plot energy here or kinetic energy here and we plot fraction of molecules or number of molecules here, simply we can write molecules. So the graph will look like this. This graph shows that most of the molecules in a given sample at any given temperature, so most of the molecules will have what? Will have this, we can say, average energy, and very few molecules will have this low energy and other molecules will have very a few other molecules will have very high kinetic energy. So in our sample, if we represent high energy molecules with this red color and suppose low energy molecules with this blue color, so what will happen? The high energy molecules which are present, which are lying near the surface, they can easily overcome the interactions and they can easily move into the vapor state, or they can leave the surface of this liquid, which is water. Now these red colored molecules, they have escaped from water, and if this beaker is open, they can easily move into the atmosphere. So this is simply what you call evaporation, the change of water liquid into water which is gaseous in nature. So now if we take the same beaker with water in it, and what we do, we close this beaker. So this is a closed sorry now this is a closed vessel, so nothing can move out of this. So what will happen? Again, the liquid or water molecules, they will evaporate and they will fill the available space here. So since they are not allowed to go out, they will be collected above the liquid surface, which is water. So as the evaporation proceeds, the number of gaseous molecules in vapor phase increase gradually. These molecules move about at random in limited space during their movement. Some of these molecules can strike this walls of the container or they can even, they will, some of them strike the surface of liquid and then they are condensed. So what we get, we get water which is liquid moving into water which is gaseous, and these gaseous water vapors or water in gaseous state is again changing into this liquid state. So here we have what you call evaporation, suppose EV, and then you have water gaseous moving into water liquid which is condensation. So after some time there will be an equilibrium between evaporation and condensation. So when this equilibrium is achieved, there will be some water molecules always available in the gaseous state, above the liquid surface. So now they are in equilibrium with this liquid. So suppose water is evaporating, moving into this gaseous form, and these water vapors are again moving into the liquid state, but there will be certain amount of or certain number of water vapors which will be there at above the surface. So these water vapors, what will they do? They will collide with walls of container as they have energy. So they will, what will they do? They will exert pressure. So the pressure exerted by vapors above the liquid surface in equilibrium with the liquid at a given temperature is called, this is called vapor pressure. So again, what is vapor pressure? It is the pressure exerted by the vapors above the above the liquid surface in equilibrium with the liquid at a given temperature, that you call as vapor pressure. So now let us discuss what are the factors affecting the vapor pressure. So most important factor is, first factor is temperature. So vapor pressure is directly proportional to temperature. So if you have water in a closed vessel at 25 degrees Celsius, and if you have water in a closed vessel at 45 degrees Celsius, what will happen? Here the rate of evaporation will be low, less number of water molecules are forming vapors. Here the amount of vapors will be very high. As a result, the vapor pressure. And second factor, we have what you call nature of liquid. So we all know different liquids have different type of interactions between them. So if we take like water, which is having hydrogen bonding between the water molecules, and if you take another liquid like acetone, it do not have hydrogen bonding, but it do have dipole interactions. There is no hydrogen bonding, but there is dipole interactions. So dipole-dipole interactions are weak as compared to hydrogen bonding. As a result, what will happen? Acetone will form greater number of vapors and it will exert high vapor pressure. Now, so what we have done, we have seen vapor pressure, which is the pressure exerted by vapors above the liquid surface in equilibrium with the liquid at a given temperature. So now let us try to calculate vapor pressure of liquid solutions. Liquid solutions. So now we will have our beaker. It will be containing two liquids. Suppose liquid A and liquid B. So this is what we have. We have our solution, which is made up of liquid A and liquid B. So both these liquids are volatile. They will form vapors. So suppose we have liquid A with its blue molecules and liquid B with its red molecules. Both of these liquids will form vapors and they will exert pressure. Now the pressure here, or the vapor pressure here, will be due to the pressure of liquid A and the pressure of liquid B, as both of these liquids are exerting pressure. Both of these liquids are forming vapors and these vapors are exerting pressure. So this PA, this is the partial vapor pressure of liquid A, and what is PB? It is partial vapor pressure of liquid B. So what we have done, we have taken two liquids, liquid A and liquid B. We have mixed them well and formed a solution. Now the solution contains A and B. Both of them are forming vapors. The total pressure is P, which is sum of individual pressures of A and B, called, what we call them, partial vapor pressure. Now if we want to calculate P, the total pressure, we have to know PA and PB. So how to calculate PA and PB? Now we can use our law, which is Raoult's law. Raoult's law. So we can, so first of all, Raoult's law will tell us how to calculate PA and PB. So according to Raoult's law, the partial pressure, it is the product of pure vapor pressure of a component and its mole fraction. So PA is equal to P naught A into X of A. Similarly, partial vapor pressure of B, it will be product of vapor pressure of pure component and its mole fraction in the solution. So now we can represent it using a diagram. Suppose this is our liquid A and this is our liquid B. So this is liquid B. And on mixing, what we get? We are getting our solution, which will be containing liquid A as well as liquid B. So here's there will be red colored vapors as well as blue colored vapors. So before mixing, here it will exert some pressure right here, and it will also exert some pressure. So this pressure is before mixing, which is P naught A, and here it will be P naught B, and here it will be P, which will be sum of PA and PB. So this is the P naught A. What is this? This is vapor pressure before mixing. And what is P naught B? This is vapor pressure before mixing of component B. So according to Raoult's law, we have calculated PA and PB. So PA is equal to P naught A mole fraction of A and plus P naught B mole fraction of B. So this is how we can calculate vapor pressure of solution. So this is vapor pressure of solution containing two liquids A and B liquid, then both are volatile. So again, let us see what we have done. So to calculate vapor pressure of liquid solution, suppose we have two liquids A and B. The total pressure will be equal to sum of PA and PB, which are the partial vapor pressures. So these can be calculated using Raoult's law. According to Raoult's law, what is the definition? We can say PA, partial vapor pressure of any component or component A, will be equal to or will be the product of what? Vapor pressure of pure component and its mole fraction in the solution. Similarly, PB will be equal to product of vapor pressure of pure component before mixing and its mole fraction in the solution. So here we have liquid A and liquid B. This is before mixing, and this is after mixing. So according to Raoult's law, P, the total vapor pressure of solution formed by mixing A and B, it will be equal to P naught A XA plus P naught B X of B. So this was the discussion about Raoult's law. Please subscribe this channel.